This is your class lesson for section 2.3, part 3. And here we'll be solving absolute value equations. And we do have a couple special cases, so we want to make note of that. The first thing we notice in problem A is that the absolute value is already isolated on one side of the equation. So we can immediately use our property that 6x plus 4 is equal to 8 and 6x plus 4 is equal to negative 8. And we solve both of those. So we end up with 6x is equal to 4 and x is equal to 4/6, and we can reduce that to 2/3. Then we have 6x plus 4 equals negative 8. So we have 6x equals negative 12 and x equals negative 2. And those are our two solutions. Okay, let's talk about B. We mentioned that having absolute values on both expressions, on both sides of the equation, really doesn't change things. We will still treat this the same way. 7x plus 9 is equal to x minus 4, or 7x plus 9 is equal to the opposite of x minus 4. So let's take a look here. I'm going to first subtract an x from both sides. And then I'm going to subtract a 9 from both sides. And then I'm going to divide both sides by 6. And we get x equals negative 13/6. Now, let's take a look at the second equation that was generated. What's important here is that 7x plus 9 is equal to the opposite of all of x minus 4. So we have negative x plus 4. So now I'm going to add x to both sides. And now I'm going to subtract 9 from both sides. Dividing both sides by 8, we get an x equals negative 5/8. So again, we get two solutions. Let's try a few more. Here we have 9 minus 2x is equal to 22. 9 minus 2x is equal to negative 22. Now that is the only way we are allowed to take these absolute values off. When you remove those, you must solve both of these equations. Let's go ahead and subtract 9 from both sides. Whoops. And divide both sides by a negative 2. Then, in this next equation that we have to solve, let's subtract 9 and divide both sides by a negative 2. We end up with x equals negative 13/2 and 31/2. Now looking at D, let me ask you something. If you take the absolute value of a number, can you ever get a negative? No, you can never get a negative. So we can just say that's the empty set. So the absolute value always generates a positive number. Okay, so we do have to recognize those. That's a special case. The absolute value can't ever equal a negative number. Okay, let's go ahead and look at E. We have to isolate that absolute value on one side of the equation, and then we're going to add 4 to do that to both sides. Now we have 3x minus 5 is equal to 10, and 3x minus 5 is equal to negative 10. We'll add 5 to both sides and divide both sides by 3. Let's go ahead and add 5 to both sides and divide both sides by 3. Okay, Let's look at F. It looks a little bit different, but what we don't want to do is change our method unless we notice something. I notice that it's equal to 0, but let's see what happens. Either 5x plus 15 is equal to 0, or 5x plus 15 is equal to the opposite of 0, which is 0. So we only have to solve one equation when that absolute value is equal to 0. So let's go ahead and subtract 15 from both sides and divide both sides by 5. That concludes this part of your class lesson.